Hello everyone and welcome back to a brand new video, and in this video I'll be solving problem expected sum from Codechef starter 71. So let's move on to the problem and see how we can solve this. But before we move on to the solution, I want to tell you guys about Newton School's coding contest. As you guys know, Newton Schools does this coding contest every month, and this month the name of the contest is Code Rush X, and the prizes are better than ever before. So you can win prizes up to rupees 10 lakhs, and along with this you can win placement opportunities in top product companies. So like if you guys want to play this for fun or you guys want to play this for placements, that is totally up to you. The contest will be on 28th of January. It will start around 9 p.m. and the contest will be 3 hours long. So there will be ample amount of time for you guys to brainstorm and solve good quality problems. So if you guys want to benchmark yourself or just win some placements, this is a very good opportunity. I will leave a link to this contest in the comments and in the description, so you guys can go and sign up from there and show, or you can flex how good you are at problem solving. So now let's move on to the solution. So we have been given a bag and the bag has n chits, and the chits are binary, so either they are 0 or either they are 1. So we have n chits where your n can be up to 10 to the power 9. Out of these, A chits are 1 and B chits are 0, and it's guaranteed that A plus B is equal to n. Now we have two players, Alice and Bob. First, Alice will take out a chit from the bag at random, then Bob will take out a chit, and they will keep alternating turns. Right? They will keep alternating turns until the bag gets empty. So they will play a game like that, and we have to answer what is the expected sum of chits that Alice gets. Right, so that is the problem. Alice and Bob will take out chits at random one by one from the bag, and we have to answer the expected sum of chits that Alice gets. Now how can we solve this? So let's move on to the solution. But before we move on to the solution, let's try to rephrase the problem so we can have a better visualization, right? So we can rephrase the problem as a binary string of length n, right? So we have s1, s2, s3, s4, so on up to sn, and we can do a random shuffle on the string, right? We can do a random shuffle on this string. Then you can say that your game is just equivalent to your Alice will take the first character, Bob will take the second, Alice will take the third, and so on, right? So that's how you can visualize the game. You can see a random binary string. Alice will take the first character, then Bob will take the second, and Alice will take the third. Then you can redefine your score. You can say your score of Alice is just sum of characters at odd indexes, right? Or even better, you can say that your score of Alice is just number of ones that you get at odd indexes, right? So that is how you can define your score. Now we have to find the expected score of Alice, right? So we can write the formula for expected value. So expected score is nothing but expected score of Alice is nothing but summation over every possible score. Let's say it is S, right? Summation over every possible score S, such that S into then the probability of occurring of S. That is how we define expected value, right? So this is just the formula for expected value over every possible score, summation over S into probability of occurring of S. And if you want to write this mathematically, we can write this as expected value of, let's say, score of Alice is nothing but summation over every possible score S going from 0 up to n, that is S into probability of occurring of S, right? That is P of S. So now we need to know the value of P of S. So that is a probability that your score is S. And as we saw previously, the score is nothing but number of ones that occur at odd indexes. So you can say that your P of S is nothing but probability that S out of A ones occur at odd indexes, right? So that is what we want to find. So now let's see how we can solve this. So we have a string S1, S2, S3, S4, so on up to Sn. In total, it will have n plus 1 by 2 odd indexes. We are only concerned with odd indexes, so like we just need to know the number of these. So we have n plus 1 by 2 odd indexes. Let's call this value k. So your k is nothing but number of odd indexes, that is n plus 1 by 2, that is number of odd indexes. Now we can see these k indexes as slots. So we have S1, then we have S3, S5, so on up to Sn, right? Whatever. Let's not make the slot, right? So on up to Sn. So in total, we will have k slots. Let's say this is slot 1, this is slot 2, this is slot 3, so on, and we will have somewhere slot k. So in total, we have k indexes, k odd indexes, or you can say k slots. And as we know, S out of these must be filled with ones. So in total we have k slots, and S out of these must have ones, right? So you can say that we have to choose S slots out of these k slots and assign them 1. So the number of ways of doing that are just let me write this better. So number of ways to assign S ones in k slots is just n, not n, it is k choose S, right? It is k choose S. So now we have assigned like S ones out of A to these k slots. Now we have A minus S. Now we have A minus S leftover ones, right? We have A minus S leftover ones, and we have to assign them to the leftover like empty spaces. So we had k slots and we have n minus k empty spaces, right? For example, here S2 is an empty space, S4 is an empty space, and so on. If we have k slots, we will have n minus k empty spaces. We assigned S1s to the slots, so now we have A minus S leftover ones. So we will assign them to the empty spaces. We will assign A minus S leftover ones to the empty spaces. So the number of ways of doing that are number of ways to assign A minus S leftover ones in n minus k empty spaces. This is just n minus k C A minus S, right? So we can multiply both of these values, right? So total ways to have score of S is nothing but KCS into n minus KC A minus S, right? So that are the total number of ways that there are to have score of S. So what are the chances of getting score S? So chances of getting score S, or you can say P of S, is nothing but like number of ways to get score S to get score S over total possible ways. And as we saw previously, number of ways to get score S are KCS into n minus KC A minus S. So it is KCS into n minus KC A minus S. And all possible ways, it is like you have A ones, so you can choose any index to assign them. So that is just NCA, right? You have n empty spaces, or you can say you have like n possible indexes, and you can assign any A of them once. So that is just NCA. So this is the value of your probability of S, or the probability of getting a score S. So now our formula for like expected score of Alice is complete. So you can say expected score of Alice is nothing but summation of I goes from 0 up to K, right? Because your maximum score can be K. So I go, not I, let's call this S, right? So S goes from 0 up to K, S into P of S, and we have found the value of P of S. It is nothing but S equal to 0 K S into KCS into n minus K C A minus S and over NCA. So now we have to evaluate this. Like if the constraints were lower, this would have been easy, right? But if you see the constraints here, the constraints are up to 10 to the power 9, right? Your n can go up to 10 to the power 9. So your k can also like go up to around 10 to the power 9. So we cannot do a normal summation here. So to like solve this, we have to simplify this. To solve this, we have to simplify this. Now, how can we simplify this? Like if you see your NCA is a constant, so we can move this out. So you can see that, or we have 1 over NCA into summation of I goes from 0, S goes from 0 up to K. So we have KCS into, we have S into KCS into n minus KC A minus S, right? So now the only task left is to simplify this expression. Now how can we simplify this? So like you can visualize this as a problem first, right? You can see that this expression is just the answer to the following problem. If you want to, let's say, make a committee of A people out of, let's say, K males and n minus K females. Also, every committee must have one male leader. So that is the problem. You want to make a committee of A people, given you have K males and you have n minus K females, and every committee must have one male leader. So if you try to solve this, let's say we iterate over S goes from 0 up to K. That is the number of male members that a committee must have, number of male members we are choosing. So number of ways to do this is K in KCS, right? We choose S male members out of K. As my committee is made up of A people, so we still have A minus S leftover slots, and they must be filled by the females. So you can say KCS into n minus K C A minus S. That is for the leftover A minus S slots we choose out of n minus K females. Now every committee must have one male leader, and as we have chosen like S male members, there are S ways to choose a leader. There are S ways to choose a leader, right? So this will be answer to the following problem. And if you match these two expressions, right, they are exactly equal. So this expression is nothing but the answer to this problem. But we can rewrite this, right? We want to make a committee out of A people that has one male leader. We can also like solve this problem as, we can first choose a male leader. We can first choose a male leader. number of ways to do that are just k, right? Because we have k male members, so we can first choose a male leader, then we have n minus 1, then we have n minus 1 leftover members, or you can say n minus 1 leftover males plus females, and we have a minus 1 leftover slots in the committee, right? As we already have a male leader, we don't care about anything else. So out of these n minus 1 leftover males plus males and females, you can choose any a minus 1, right? So you can say k into n minus 1 c a minus 1, right? So this is also an answer to this problem. So these two expressions are equivalent, right? These two expressions are equivalent. So I can like just replace this expression. I can just remove this summation and put k n minus 1 c a minus 1. So my expected score is nothing but 1 over NCA into k into n minus 1 ca minus 1, right? And like if you expand these two terms, we get n minus 1, n minus 2, so on up to n minus 1 minus a minus 2 over a minus 1, a minus 2, so on up to 1, and into k we have n into n minus 1 into n minus 2, so on up to n minus a minus 1, and we get a minus 1, so on up to 1. These two cancel out. I can cancel this stuff out and I can cancel this stuff out, and like if I shift this one to the inside, this becomes a plus 1, right? So this can just be written as n minus a minus 1, I think, right? So I can cancel this entire term out as well. I can cancel this and I can cancel this. So this just becomes k over n over a. This is just a into k over n, right? So your answer is nothing but your expected score of Alice is nothing but a into k over n, and that is your answer, right? So you just need to like evaluate this expression under a modulo and that will be your answer. But like this involved a lot of computation, right? A lot of like thinking. You can like also think about this problem in a very, very different way, right? So you can say that you have like k slots, right? We have k slots. This is slot 1, this is slot 2, this is slot 3, and so on up to slot k. Then you can say that your like expected score of Alice is nothing but summation over probability of every slot being a 1, right? So you can go over every slot, like, right? First you can check slot 1. What is the probability that this slot will give us a 1? What is the probability that this slot will give us a 1? So if you think about this, we can place a 1 here. Then we have n minus 1 leftover indexes, and we have a minus 1 leftover ones, right? So there are in total n minus 1 ca minus 1 ways to do this, right? N minus 1 ca minus 1 ways to keep a 1 at slot 1, and over all possible ways, that is just NCA, this is all possible ways, right? So this is the chance, or you can say probability of there being a 1 at slot 1. Chance that your slot 1 has a value of 1, right? Similarly, you can find the same value for slot 2, slot 3, and so on up to all the k slots, and value will be same for every slot. So you can just multiply this with k. So you can say that your expected score for Alice is nothing but k into probability that your slot 1 has a 1, right? Because all the slots are equivalent. So that is k into the probability that your slot 1 has a 1. And as we saw above, the probability that your slot 1 has a 1 is nothing but k into n minus 1 ca minus 1 over nca. And like if you solve this, you will again get the same value. You will get that your score of Alice is nothing but a into k over n. So like you can solve this both ways. So like when you get a problem, don't always like just blindly apply the formula for expected value. Try to think in different directions if possible, right? Because it's possible that like if you apply the formula for expected value, the computations might become very lengthy and cumbersome. Like you saw here, like we took a lot of steps to solve when we applied the formula directly, but like when we thought of this in another way, like it was quite easy to solve, right? So these are the things that you need to keep in mind for such problems. Now if you guys want to see the code for this, code is nothing like that new. We have your value n and we have your value k, that is just required. So your answer is just a into required, that is a into k over n, right? That is mod inverse of n. So that is the entire solution. And if you guys have some doubts, feel free to ask in the comments or like join my Discord server. I'll be more than happy to answer your doubts there. And I will see you guys in the next one. Bye bye.